Hello dear students, welcome back to my YouTube channel. So I guess I'm audible and visible to all of you. Just let me know in the comment box if I'm audible and visible to all of you. Good vibes. Good evening, beta. Am I audible and visible to all of you? Yes, yes. One second. Okay. So let's start now the lecture number 8. Okay. So in the previous lecture, we discussed about torque, right? One second. It is good. Yeah. Hello, beta. So I guess my screen it gets stuck now. Let me refresh it once. Let me refresh my screen. Okay. So if you know that now, yesterday we were discussing about. Hello, beta. Yeah. So yesterday we were discussing about torque. Okay. And the equilibrium positions of the torque. Today we will be discussing lecture number 8. Today is lecture number 8, right? Look now. What we will study in this lecture. This lecture is very important. Okay, suppose we are having a coil, okay, or if we are talking about uh, electrostatics, right? These lines represent electric field lines, right? Now if we are having a dipole, electric dipole placed here with some angle theta, you can see now, minus q plus q. If slightly displaced, if slightly displaced, slightly, right? So this dipole will perform SHM, simple harmonic motion, and the time period for that thing is 2 pi under root of I divided by what we are having then, PE, right? So this thing we know from the electrostatic chapter. If we are having a dipole and this dipole is placed a theta degree, right? And if you are just displacing it, it will perform a SHM, simple harmonic motion. Time period for that SHM is 2 pi under root of I by P. I is moment of inertia, P is dipole moment, and E is electric field or electric field intensity. In the same way, if we are having coil, if the coil is slightly displaced, if the coil is slightly displaced from its equilibrium position, from its equilibrium position. And what is the equilibrium position? Yesterday we concluded it, no? 0 degree and 180 degree. Equilibrium position. Equilibrium position. Then it will perform SHM. My magnetic coil will perform SHM, and time period for that SHM is same. Time period of that SHM is same, that is T. T is equals to 2 pi under root of I divided by, in place of dipole movement, we are having magnetic movement. In place of electric field, we are having magnetic field. So I can write here, sir, what is I? I is moment of inertia. It is moment of inertia. What is M? magnetic moment. Magnetic moment. What is B? Magnetic field. Magnetic field. Done? Okay. So we are having maximum formulas from electrostatic only, right? Little bit of manipulation, then everything is same. Now, if you have the memory now that whenever we are displacing a dipole inside an electric field, we need to perform some extra work done. Okay, let us suppose this dipole is currently in this particular position. Okay, in this position. Now, if we want to rotate this dipole, we need to apply some extra work done here. If we want to just turn it, no, so we need to apply some force. Done. We need to apply some force. In the same way, in this particular chapter, if you want to rotate your coil, which is containing electric current, so what is the amount of work done that you need to apply to rotate your coil? Let us discuss that particular part now. Okay, look now. Do you know what is work done? Do you know what is work done? Is it force into displacement? Is it force into displacement? But that thing we can use in what? A rectilinear motion. Here we are having a rotational motion. So I can write work is equals to torque. Work is torque into displacement. So here we are having angular displacement. It is what? Angular displacement. Work is torque multiplied by angular displacement. So we know that work is dW, torque is tau, displacement is d theta. Done? Better just give me 1 second, okay? We're having some unwanted guests in the list. So I need to remove these. Okay. Yeah. So I just remove this unwanted guest now from my list. So we are having Netic watts. What is torque? But we are not dealing with 11th here, no? We are dealing with 12th only. Okay. So this is not the right place to ask these doubts. Hope you will understand these things. Okay. We are dealing with what? Magnetism. So here I cannot explain you what torque basically is, what is angular displacement, what is work, right? Look here. So what is torque now? Sir, I guess from this chapter we know that value of torque. Is it m cross b or is it mb sine theta? Yes, sir, it is mb sine theta. So now you can see here, now I can write dw. In place of torque, I will write mb sine theta. Then we are having d theta. But it is small amount of work. I need a large amount of work, so I will use integration. So I will use integration. Look, if you want to grow from smaller quantity to a larger quantity, we will use an integration. If you want to go from larger quantity to smaller quantity, you need to differentiate. dW is a smaller quantity. It's small, right? Small. And W is large. If you go from small to large, use integration. So that means if we are rotating it, so I will rotate my dipole from theta 1 to theta 2. Look, the differentiation of dw would be w. M is constant, B is constant. So I need to use the integration only for sine theta. Sine theta d theta. W here, so we are having MB. What is the integration of sine theta? It is minus cos theta. Upper is theta 2, lower is theta 1. W. I will take minus outside, it is minus MB. So what we are having? We are having cos theta. Upper is theta 2, lower is theta 1. Okay, look now. W minus MB, I will write upper limit minus lower limit. Okay, so I can use one more thing, that is I can take minus inside, so it will become now MB cos theta 1 minus cos theta 2. Okay, so this is the final relation of my work done. That means if somebody will ask you, we are rotating the coil from theta 1 angle to theta 2 angle, what should be your work done on it? You can write it is MB cos theta 1 minus cos theta 2. Okay, okay, what is theta 1? So theta 1 simply indicates initial angle. Theta 1 is initial angle. And what is theta 2? Theta 2 is final angle. Theta 2 is final angle. Done. This one is the final angle. One more thing now. One more thing that we know. Do you know what that thing is? Do you know from chapter work power energy? We are having a work power. We are having a theorem, work energy theorem. Do you have any idea about work energy theorem? Can I write now? Work done by external force equals to change in potential energy. Dasif, beta. So do you know the work done by the external agent or a force equals to change in its potential energy? Done. So I guess work done is nothing. It is MB cos theta 1 minus cos theta 2. What is change in potential energy? Is it final minus initial? Is it final minus initial? Yes, sir. It is final minus initial. Okay. If we will take a reference point. Okay. For reference point. Ajay beta, we started this series na in English only. Okay. That's why na, because basically my course students, they're from the South India. That's why I started this lecture series, just because of those students. That's why I'm teaching in English. Okay. Okay. So this particular thing is what? Change. This is change in potential energy. Okay. If you want the potential energy, I will write here for PE. PE means potential energy. We need to specify a reference point. And as per NCERT, a reference point is theta 1 equals to 90 degree. Okay, this thing we need to understand according to NCERT. Once again, according to NCERT, theta 1 should be 90 degree only. It is according to NCERT. You can see here, right? So now can I write now here? Look, and so yes, I can write MB theta 1. It is cos 90 minus cos, I can write theta here, no issue. Done. At the reference point where theta is 90 as per NCERT, potential at this particular instant is 0. Can I write now U final minus 0? Can I write like this? Yes, sir. And cos 90 is also 0. Therefore, I can write here, U potential energy is equals to minus times mb cos theta, or U equals to minus m dot b. It is m dash b, m dot b. So first thing that you need to remember, that is W, work done. It is mb cos theta 1 minus cos theta 2, and my potential energy is minus mb cos theta. It is what? mb cos theta. Done? But I am teaching online. Huh? I am from, I don't disclose the name, but still I am from online, you can say the edtech. No? Okay. So I guess this thing is very clear to you now. Okay, now next topic is force between parallel moving charges. Next topic is force between parallel moving charges. So what is the meaning of this thing? Okay, what's the meaning of this? Let's suppose we are having two charged particles. Look, plus q, it is going with velocity v in this direction. Suppose one more charged particle plus q, it is going with same speed v. Okay, if the distance between these two r is d, let's suppose d, no? D. Two charged particles going along same direction and the distance between them is d. Okay, I guess one property that we know, like charges repel. We know it now. Like charges repel from electrostatic. I guess this property we concluded in electrostatic chapter, that if we are having two like charges, they will repel each other. We know it. Done? Okay. So what will be the force of repulsion between these two? So I can write Fe, electric force. Fe I can write, it is electric force. Electric force. Is it equals to K, that is 1 over 4 pi epsilon naught? Is it Q1, Q2 divided by D square? Can I write it equals to 1 over 4 pi epsilon naught? Is it Q square by D square? Yes, sir. Is it Q square by D square? We know this thing from electrostatics. Okay. But one more thing is there, no? If charged particle, positive charged particle is going from below to up like this, no? So I guess you know one more property. If charged particle is going along this direction, the current will be associated with it. So can I write I current is also going in this direction? Right? I current is going along this direction with same distance d. Why, sir? Because flow of charge is current and direction of current is along the positive direction of the particles. Positive particles are going above. Positive particles are going away, above. So you can call it current is going also above. Okay. Now look now. Take your right hand. Take your right hand. Take your right hand. So if we are talking about this one, so the magnetic field here will be inside. Magnetic field will be inside. And if current is going along same direction, I guess it would be attractive force. there will be attraction due to same direction of current, and we proved this thing also in our previous classes. Due to same direction of current, we had proved this thing also, no, in previous classes. Look now. Okay, how to find the magnitude of this force? Fm is magnetic force. Is it magnetic force? Yes, sir. And what is magnetic force? Do you have any idea? If both are in opposite direction, that means if one is going upwards, one is going downwards, there will be a repulsion. Okay, and this case also we discussed it in back classes. Okay, so what is Fm? We're having two formulas to just conclude it. Is it QV cross B or IL cross B? What initially we are having? I guess initially we are having charged particles. Initially we are dealing with charged particles. We are not dealing with a current. Initially, now you can see now, look, you can see here, moving charges. If there is a moving charge, so we need to apply the formula of moving charge, and that is QV cross B. I can write Q V cross B. B is inside, V is upwards, so the angle is 90 degree. So I can write it is Q V B sine 90 degree, and sine 90 is 1. So I can write it is Q V B only. Done. What is the value of this B? Any idea? What is the value of this B? Why I'm just having blurry face, no? Okay, now it is good now. Due to autofocus, it gets right. Okay, what is B now? So B is the magnetic field. Is it nu naught by 4 pi? Done. We're having now Q V D sine theta divided by dq. Biot-Savart Law. We know it now. Look, I can write nu naught by 4 pi. Q is Q, V is V. 1D cancel out, so we are having D square only. So here we are having sine 90 degree also. Okay, sine 90. Why? Because D is in this way and V is in this way. So angle is 90 degree. D and V. So this value came out to be nu naught by 4 pi QV by D square. So I guess we are having QV, then is it nu naught by 4 pi QV by D square. Okay, look here now. So can I write now magnetic force came out to be nu naught 4 pi Q into Q square, V into V square divided by D square. First equation, second equation. So we are having now two equations. Sachin Pandit, hello beta, of VVS Soul, hello beta. Okay, so we are having now two equations. We are having now two equations. Let us divide these two equations now. Okay, look now. Can I write force due to magnetic divided by force due to electrostatic force? So Fm came out to be, is it nu naught by 4 pi Q square V square by D square? Is it like this? Divided by, what is Fe? Is 1 over 4 pi epsilon naught Q square by D square. Look here now. 4 pi cancel out. Q square cancel out. D square cancel out. So I guess my answer came out to be, is it nu square? So we are having V square. There we are having epsilon naught. One more identity that is very important, that is speed of light, c is equals to 1 divided by under root of nu naught epsilon naught. I can write c square is equals to 1 divided by nu naught epsilon naught. So I can write nu naught epsilon naught is equals to 1 divided by c square. So I can write in place of these two things, I can use 1 by c square. So I can write v square by c square or equals to v divided by c whole square. Sir, what is c? What is basically c? C is speed of light. Is it speed of light? Yes, sir. This is speed of particle. Speed of particle. So as you know one thing, sir, what? That c is more than v. C is ultimately more than v. So therefore, I can write Fm by Fe. Clear? Is it V by C? If V by C, it will be, so I can write here now, V by C is less than 1. Is it less than 1? I can write here, it is less than 1. Therefore, I can write Fm, magnetic force, is very less than my electrostatic force. So this thing is giving you a guarantee that if we are having a concept in which both things are being applied, that is magnetic force as well as electrostatic force, we don't need to consider magnetic effect. We only need to consider electrostatic effect. Why? Based on this, all these manipulations, we conclude that electrostatic is the dominant one. Electrostatic is the dominant one. We don't need to consider the magnetic one. Consider only the electrostatics one. Let us suppose if we are having two charged particles. Two charged particles are in some motion, upwards, downwards, cross, something like that. So we have two concepts in the mind. Charge is flowing, current is there. Current is flowing, magnetic force will be there. One concept. Second concept, charged particles are flowing, electrostatic force will be there. So which concept you can use then? You need to use only that concept which is related with the electrostatic properties, because here electrostatic is the dominant one. Done? Okay, look now. If let us suppose you will have a numerical. Suppose, okay, charged particles plus q plus q, both are going in this direction. So just tell me, we know there will be a force, but is this force an attractive one? Is this force will be an attractive one or a repulsive one? Okay, sir, positive repulse. So you can write according to the electrostatic concept. Electrostatic concept, they will repel. They will repel. If you can use magnetic concept, same positive, same current, they will attract. So what is the final answer? Sir, we know that electrostatic is the dominant one, so repulsion is the correct answer. So repulsion will be the correct answer. One more thing. If we are having electron is going in this direction and a proton is going in this direction. Okay. Just tell me there will be a force. So is this force a force of attraction or repulsion? So what is your answer? Sir, if we are talking about electrostatic, positive, negative, they will attract. They will attract. If we are talking about the magnetism, look, if I is going upwards, so due to this, current will be downwards. Positive is going upwards, current will be upwards. Look, different direction of current. So based on this thing, you can write it is attractive. No, it repulsive. Repulsive. So you can write according to the magnetism concept, it is repulsive. But what is final answer? So my final answer is attractive. Why? Because electrostatic is the dominant one. No? But if you want the notes of my class, no, for that thing you need to join my Telegram group. You do one thing, go to the channel description part, you will find a Telegram link. Click the Telegram link, okay? And after finishing my lectures, I am just uploading these PDFs there. You will find couple of PDFs of previous chapters, electrostatic, capacitor, current. Now within 2 days, I will be uploading the whole chapter notes from 1 to the 10th or 11th no, in my Telegram group. Okay. So let's do one more numerical. Okay, one more numerical. Okay. Suppose we are having something like that. My x-axis, my y-axis, my z-axis. We are having a loop, and my loop is going in this way. This is my loop. This particular thing is my loop. It is bended. Okay, look, my loop is like this. Okay, like this. Suppose if this thing is my loop now, so it is in this way now. Okay, look, current I is flowing through this loop. Current I is flowing. Just saw the direction also. The loop is in this way. Current is going clockwise manner. And if you are just, the B is breadth of it, and this A is the length of it. Find, question is find M net magnetic moment. Sir, how we can use the concept of this no magnetic moment? We know if there is a coil, for that thing we can use it. But this coil is bended, no? Look, if we are having something like this, no? Look, something like this. Okay, with current I, so I can use M equals to NIA, number of turners, current and area. I can use it now. But here, now it is something like this. It is bended, so we don't have any formula for bended numericals. So what you need to understand here, sir, can I take here two wires? One wire in this way, and parallel to this one wire, we will consider one more wire. I will take one more color. One wire, one more wire. One wire I will attach it to the upper one, and lower one I will just do like this. Now we are having two loops. One loop, second loop. For this loop, what will be my M? I guess it is NIA, NIA. What is N? Sir, N is number of turns, that is 1. Current is I. Area. What is area? Sir, it is AB. It is AB. If you're taking your right hand, you will see now, look, curl your fingers in the direction of current. Your thumb is inside. If it is inside, you can write minus K cap. So my M came out to be, M1 came out to be, it is minus I. Okay, I will not write in this way. I will write here IAB minus K cap. Now let us talk about this one now. We are having M2. It is NIA. It is NIA. N is 1. I is I. Area. What is area? Area is simple AB now. This is A, this is B. But where is the direction of it? So it is coming downwards. Downwards is minus J cap. Minus J cap. So you can write, sir, my M2 came out to be, is it I, A, B minus J cap. You can see, sir, it is like this, minus K cap and minus J cap. What is net now? What is net magnetic field? Net. So what will be the M net? Sir, M net is equals to, is it I, A, B minus K cap plus I, A, B minus J cap. I will take I, A, B minus K cap minus J cap. This is my final answer. You don't have Telegram, beta? Or BVN Sol? You don't have Telegram? Okay, one more numerical. One more numerical. If we are having a loop like this, x-axis, y-axis, z-axis, okay, and my loop is in this way, a square, current I is flowing in clockwise manner. Find M. I guess M is NIA only. Sorry, NIA. N is not vector, A is vector. What is N? N is 1, I is I, A is A square, and you can write your hand and it came out to be inside. So it is what? Minus K cap. So therefore, minus M came out to be I A square minus K cap. There is no other way to get these notes, right? Either you need to write in these notes, or you can just get your telegram and join my telegram. Only two options. If now let us manipulate this numerical, let us change some parameters of it. What, sir? Look, let us change it some parameters. X-axis, y-axis, z-axis. Now if we are having the loop, if we are having my loop, and my loop is in, now I will just increase the color, my loop is inclined to it. My loop is inclined. This is my loop, and you can see it is inclined. Okay, so this is my angle theta. Firstly, my loop was in this way, x-axis, y-axis, and z-axis. Now it is slightly tilted, so it is x-axis, and this is my tilted way. Okay, one second. So same parameters are there, sir. This side is A, this side is A, this side is A. Current I is flowing the same manner. Same manner. Okay. What we can do now, we know that if something is between my axes, so we need to resolve these things. We need to resolve according to the vectors. So we will get one component along x-axis, one component along y-axis. Okay. Done. Along x-axis and along y-axis. So if we are talking about one axis, so x-axis means in this way. This is my x-axis. Just could you tell me the which component this x-axis is? It is cos theta. Look, if it is this one, so this is cos theta component. Cos theta component. Okay. So I guess here it is inside. Take your right hand. My M is inside, so I can write for this only. This only. It is M cos 30 degree, and direction is inward, that is minus K cap. For y-axis, it is completely in this way now. Completely in this way. Okay. You can take your right hand, and you will see. Firstly, it is sine theta, so I can write it is M sine 30 degree, and if it is completely in y-axis, so you can take your right hand, you will get it in the I-axis, I direction, so I can write plus I. So that means we just divide these two things into these two parameters, So that what is M net now? Sir, my M net now came out to be, is it M cos 30 degree? Yes, sir, which is minus K cap, plus, is it M sin 30 degree? Yes, sir, in plus I direction. What is M? NIA. I, A. What is A? A is A square. Cos theta. Cos theta is under root 3 by 2. Minus K cap. Plus, it is I A square same. Sin theta is 1 by 2 plus I cap. I will take I A square by 2 common. So we are having under root 3 minus K cap plus I cap. This is my ultimate answer. This one is my ultimate answer. Done. One second. 1 second, beta. Okay. Now let us start new concept or new topic known as bar magnet. Bar magnet. New concept, new topic known as bar magnet. What is it? Sir, bar magnet. Okay. So bar magnet simply indicates that we are having a something like this magnet. Okay, like this. One pole means north pole, n means north, one is south pole. Done. And pole strength of this north pole is plus m. Pole strength of south pole is minus m. By convection, we know one thing, that these lines, magnetic force lines, these coming out from north pole, from outer side, and goes towards south. Magnetic lines, no, field lines goes from north to south outwards, but inside they are going from south to north. They are going from south to north. Okay. And if we are talking about the magnetic moment, so my magnetic moment will be from north to south. This is my magnetic moment. Either we can use the right hand rule, okay, or for this coils, here it is simply from south to north. From minus m to plus m. Why my face is blurring now? Okay. Remember these things. So what is m? I will write here. 1 second. What is m? Sir, m is pole strength. Pole strength. Like the Q in electrostatic. How to find magnetic moment? I can write m times 2L. What is 2L? 2L is the length of my magnet. You can take L also. Now there is no compulsion on this. It should be 2L. You can take L also. No worries. So we are having formulas. M is it NIA? One formula for coils. If we are having bar magnet, so it should be M2L. You will get numericals now. You will get numericals in previous examination of NEET. Numericals was if we are having a magnet. If we are having a magnet, this is my magnet, and length is L. Now the length is L. Just remember one thing: the length is L is given to us. Strength, it is plus M. This strength is minus M. It is given to us, and its magnetic moment is M. Now, if we bend this wire in this way, if we bend it, 1 second, if we bend it, no, how so? Look. Okay. No, it's not correct. Yes. If we bend it like this, so I guess this length will be L by 2. This length is L by 2. This pole is plus M. This pole is minus M. Done? Look, we want to find the new magnetic moment. New magnetic moment. Look, if this distance is something, let's go R. Okay. So what will be the new magnetic moment? Sir, it will be M R. MR, no? But what is R? We don't know, no? Look, two equal sides. L by 2 is equal, L by 2 is equal. Two equal sides will have a two equal angles. Equal angles. Two equal angles means 60, 60. So this could be 60 now. So we are having the equilateral triangle. So L came out to be L by 2. So it is M L by 2, which came out to be M L by 2. Previously, my M is how much? It is ML only. So can I write now M new is equals to M old divided by 2. Done? And one more thing that you need to know now, that M pole triangle is proportional to the area of cross section. Area of cross section. You need to remember this point. What, sir? My pole triangle depends on the area of cross section. If my cross section is more, magnetic pole triangle is more. If my area is low, my pole triangle will be less. Done? Let us suppose now we have a magnet. Okay, suppose everything is based on suppose. If we are having a suppose, we are having a magnet like this, north pole, south pole, pole triangle plus M, pole triangle minus M. Length is x. So what will be magnetic moment? So it is mx. So mx will be my magnetic moment for this bar magnet. Done? Okay. First thing, we will cut a long length. So what does this thing indicates? Look now. It is simple. Now we cut the whole thing into two equal parts. 1, 2. Okay. So we cut it now. So we know that, look, pole triangle is plus M. It is plus M. Here it was minus M. Okay. We cut it. The length is same x for both of them, x. Now this area of cross section for first one, it decreases by half. So I can write it is a by 2. If it is a by 2, so my pole triangle is also divided. Okay. So what is now new? M dash? Is it m by 2 x? So is it mx by 2? Mx is m. So is it m by 2? If you are cutting your dipole along the line, so the new dipole moment will be all divided by 2. Okay. Second case is if you are cutting it perpendicular to length. Perpendicular to length means that if we are having it in this way, look now. Look now. I guess you can see now. Now length gets divided. Length. If it is north pole, south pole, so automatically this will become a north pole. This becomes a south pole. Okay. This is plus M minus M plus M minus M. Area of cross section is same now. So now for this one, what you need to write? Sir, M double dash. It came out to be M. M is same. The length is x by 2. So which is mx by 2. Mx is old, so I can write M double dash came out to be M by 2. In both the cases, answer is same, but the path is different. If you are cutting your dipole along the line, magnetic moment will get half. If you are cutting your dipole perpendicular to the axial line, magnetic moment will be the half. Okay. Now, if you are having multiple magnets, then how to get the magnetic moment? Nick, suppose beta, look now. This is important and interesting one also. If you are having two magnets, one magnet, one more magnet. These are identical magnets, identical. That means same. North pole, south pole. North pole, south pole. We know one thing, that magnetic moment is from north to south if it is identical. So if it is M, this would be M. Angle is 0. So theta between them is 0. So what will be the m net? Sir, m net is, I guess, 2m only, no? M net is 2m only. Yes, sir. But if now, what, sir? If now we are having one magnet, one more magnet, identical magnets now, but north pole, south pole, south pole, north pole. You can see first m is in this way, second m is in this way. Both are opposite to each other. So what will be my m net? M net came out to be 0. Okay. Now if we are having perpendicular to each other, if we are having now perpendicular to each other now, look now beta, north pole, south pole, south pole, north pole. See now, magnetic moment from south to north, m. Magnetic moment from south to north, m. Angle between them is 90 degree. What is m net? You can write, sir, m1 square plus m2 square plus 2 times m1 m2 cos 90 degree. Cos 90 is 0, 0. So I can write m1 is m square plus m square divide. So root. Is it how much? M root 2. M root 2. If you are, let's say, if you are having square, okay, one more thing. If you are having something like this, now look. 1, 2, 3. These are identical, okay? This one is not. These are identical. Look now. South, north, south, north, south, north, south, north. Find magnetic moment. From south to north, here it is M. From south to north, it is M. South to north, it is M. South to north, it is M. So can I write it like 1M, 1M, 2M? I will write here, we came out to be 2M, 2M. Okay. So M net will be somehow right now. It is M net. So I guess M net came out to be same, na? M1 square plus M2 square plus 0, na? 2 times M1, M2 cos theta root. This term will be 0. Why? Because this is 90 degree. M1 is 2M square. M2 is 2M square. Then it is root. So can I write it is 2M root 2? Is this answer? From root 2, no? Now, if somehow we are having inclined, not 0, not 180, not 90, if we are having inclined by some different angles, 37, 45, 30, 60, now how to deal with those numericals? Let us suppose now, if we are having something like this, now look. Okay. Now this angle is, let us suppose 60 degrees. Suppose, north, south, south, north. How we can do this numerical? Look, one will be from north to south. Is it 1m? One will be from south to north. This m. Look now. So can I write it in this way? Sir, m 60 degree. What is formula for this one? M net. M1 square, M2 square, M1, M2 cos theta. But as we know from the vectors, angle between vectors is either head to head or tail to tail. It is tail to head now. So I will take it in a like this 60. So this will become how much? 120. So theta is 120. So my m net came out to be m square plus 2 times m square. Then we are having cos 120 degree. Done. So it is 2m square plus 2m square. Then we are having cos 120 degree. Done, beta. Okay, one more thing. How to break down cos 120? Okay, look, it is 90. 90 plus 30. It will become 120. 90 minus 30. 60. The value of 60 and the value of 120 is same. Okay. 1 by 2 only, no? So we are having one more shortcut. Now, shortcut. That is, if you want to find net, so the net would be 2 times m. M is 2m. Then cos theta by 2. One more formula. Okay. So why 2m? Na? Here is 2 only, no? M only. So is it 2m cos 60? Cos 60 1 by 2. So the answer is m only. Just use this formula, you will get m only. Okay. Let us do one more numerical. If we are having a dipole like this side is plus m, this side is minus m. So length L. Dipole moment will be magnetic dipole moment, m into L. Now we bend this one into this arc. So the length will be same, no? The length will be same L. Okay. This is center of this arc. Radius. One pole plus m, second is minus m. Just join these two. Equal sides, equal angles. 60, so this will be 60 now by triangle rule. It will be also R. But we need answer in L. So how we can get it? We know one thing, that arc is equals to angle into radius. Arc is L, angle is 60. 60 is how much? It is pi by 3. Radius is R. So R came out to be 3L by pi. For this one, my magnetic moment will be M into R. M is M, R is 3L by pi. Is it 3 by pi M into L? This is old, so I can write 3 by pi into M. This one. Okay? Done? Done, beta? Okay. So if we are having now a solenoid, look, if we are having a solenoid, look, a current carrying solenoid, current I is flowing. Look, current I is flowing. So how to find magnetic moment? Take your right hand for this loop only. Current is going, okay, in this way, no? Now the loop is in this way, so it will be in this way. loop is coming in this way. Which one, beta? Daksh, root 3 pi, root 3m. Which one, root 3m? Which one? Had I done something wrong? Which one? Okay. Take your right hand. Just take your right hand. Okay. Current is going. Okay, no worries, beta. If current is going in this way, now we are just watching it from this way, so it is going clockwise. So this will behave now. 1 second. So I guess no worries, beta. गलती इंसान से होती है ना. So if I this loop is in this way now, look, it will be in this way. Current is going I. Here it is I. Take your right hand. Current is going in this way. Now it is in this way. So my M will be in this way now. M. So my M will be here. This is my M. So if M is here, so this will behave like a south pole. This will behave like a north pole. Long solenoid case. Long solenoid case. Okay. Now, if you want to just do from a toroid, now we are dealing with toroid. Toroid. Okay. This current I is coming in this way. I current I is leaving. That means my current will go in this way and come from in this way. Go in this way and come from in this way, right? This is my direction of current. This will be my direction of current. No, it won't be in this way. No? It will go here, then here current, here current, here current. Okay, it will be in this way. It will change our direction from this one. Okay. Now take your right hand. Take your right hand. So from this particular part, M will be here. From this part, okay, from this part, M will be here. Take your right hand. No? For same way. If we are talking about it now, M is in this way. Here M is in this way. Same here M is in this way. Same, no? So what will happen now? Each and every one is having diagonal component. Like now, they will cancel each other effect. So for toroid, my M net is 0 for toroid. For toroid, M net is 0. For toroid, M net will be 0. M net will be 0. Done? Yes, toroid for M net is 0, no? Why? Because it will cut. So देखो यहाँ पे let's suppose there we will have 1M. Here we have 1M. So for this one, what is M net? Sir, we know that equal opposite it is 0. For one it will be like this, one it will be like this, one it will be like this, one it will be like this. No? So for each everyone M net is 0. So the whole M net for toroid is 0. Let us do a numerical then. Let's do a numerical. Numerical like we are having a solenoid. We are having a solenoid where n is equals to 800. Area of cross section is given as 2.5, 10 to power minus 4 meter square. Current is given as 3 ampere. Find magnetic moment. I guess magnetic moment is nothing. It is NIA. N is how much? 800. Current is how much? 3. And area is 2.5, 10 to power minus 14. Sorry, 4. So 20 cancel. So here what we have here? Minus 2. So we have 8 into 3 into 25 divided by 10 into 10 to power minus 2. It will go outside up. It will be minus 3. Done. So we are having 25 into 3, 75, 75 into 8. So we are having, I guess it is 6, 10 to power minus 2. It is minus 1 then. My answer is 0.6 no? I guess my answer is 0.6. Huh? 0.6, right? No? Yes, 0.6. Okay. One more numerical. Within 5 minutes, we will end this lecture now. Within 5 minutes. Okay. If we are having a solenoid, if we are having a solenoid and the solenoid is placed in uniform magnetic field. So could you just tell me how to find force? That is 0.6 now. 6 10 to the power minus 1 is 0.6. So could you just tell me how to find force now? If we are having a solenoid and this solenoid is placed in uniform magnetic field, just tell me what will be the force or how to find the force. And how to find torque. Torque also. How to find force, which equation we can use to get force, and how to find torque. Look now. As we know from the previous class, if something is placed in uniform magnetic field, if it is uniform magnetic field, then force is 0. Yes, Daksh, perfectly. Force is 0, but torque is not 0. Torque will be m cross b. M cross b. So I can write it is mb sine theta. So you can just place the values and you will get your answer. Done? Done, beta? So I guess we are done with today's class. I hope you enjoyed the session. So now, how many sessions are left for this chapter? I guess two or three more sessions. 2 or 3 more sessions. Okay. Within 2 or 3 days, we will complete this topic. Then afterwards, we will start next chapter. Okay. I guess we are done with today's session. Or if you have any doubts or anything like that, you can just join my Telegram group. There you can just ask me your issues. Thank you, beta. My Telegram group, I will just. No worries, beta. No worries. Okay. So you can write my name as Telegram. Shakur Sir Physics. And one thing now, because these basically this course is not designed for those students who are not comfortable with the basic terminologies. To be frank, right? If you don't know the basics, you cannot understand the lecture. Basic is doesn't mean that you need to go depth into it. No? that you need to watch from the electrostatic chapter. I didn't derive much formulas in this particular one. Do you know why? Because I had spent more time and much more time in electrostatic defining those derivations. Same derivations we can use here, no? I placed many derivations, sir. How to be? It will be the kind of stable, unstable equilibrium things. Torque. How to get this torque? Okay, these basic terminologies we discussed it there, no? So I am not going to repeat these things. So you need to watch from the electrostatic, and you can see now I am just taking the concept of doing numerical, doing derivations. That's all. Because my aim is to clear your syllabus within 1 month. Na? That's coming month. Before 15th of this next month, my aim is to complete my whole 12th syllabus. Then we will start the 11th class. Okay? Because let's suppose you are just preparing for your NEET or JEE, and currently you are in 12th. You are studying for your boards, CBSE or what other board you are from. So just complete 12th. Then within 4 months or 3 months, we will complete your 11th. That means before December, your 11th and 12th is finished. If let's suppose you have wasted your 11th, no issues. I am going to start your 11th now. So from next month, we will start 11th. And in 3 months or 4 months, we will complete your 11th. So you are having then time to just revise for your board examinations. So there you are having January and February, right? Just revise your this kind of board things. Then in after CBSE, I am just coming with the great numerical series also. Okay, but modern physics that will look in coming days, we will be starting EMI that will take I guess 4 to 5 days, AC 4 to 5 days, EM wave is 2 days, that were an optics 10 days, then modern. So within after 15 to 20 days, we will start modern physics. Because the whole syllabus will end now before September. It is August, so my deadline is 15th September. Before 15th September, I will complete your whole 12th complete. And 100%, you can just cross check this whole syllabus from your NCRT. Just open your NCRT, just see my content. Then you are from your any institute, just open your module. Okay, open your module also. Open your DPP from any institute, right? You can just do one thing now, just do these things. Just cross check my content then. Okay. The only thing now why my syllabus is getting complete in a shorter way, I'm just coming to the point. I'm not explaining just like to 10th student or 9th student, right? You're in Grom student, you're in from 12th. You're in dropper batch, right? Or a fresher batch. So I guess you are having some sort of guts, no? Just go through your books. So I guess I need to leave now, no? I have a lot of classes for tomorrow also. I need to take rest. Thank you, beta. Thank you, bye. If you're having any doubts or anything like that, you can just let me know. Okay. So if you are having any doubts or any issue or any kind of suggestion or anything that you're having for me, you're most welcome. Bye, beta. Good night. Bye. Bye, all.